Saxon Algebra 1, lesson 114. I have to tell you that I just trapped and released a fly that was in my house, and I used this piece of paper. You know, he was on the screen of my window, so I took like a plastic, like a Tupperware container, and I trapped him against the screen, and then I used this piece of paper to slide, like the cup was like this, and I slid this, and then I carried him like that to the door. So this has fly footprints on it. Exciting, right? Okay, lesson 114 is about exponential growth. Happy days, we're going to use the calculator for these problems. That's always fun. Once we start using the calculator for some things, it is not an open ticket to use it for anything you want. Hang on just a second, I need to get my charger or my phone's gonna die. Okay, I'm back. When we need to use the calculator, it's fine to use the calculator. Hang on, the camera's gonna go wonky while I plug in. Oh, that wasn't too bad. But we don't just start doing everything on the calculator. And it's tempting because it'll be nearby and it's like, oh, 75 times 15 would be so easy on the calculator. But we're not gonna become those people. We're gonna continue to do most of our math in our heads, or on paper and pencil. On paper and pencil, no, with paper and pencil. But you do need to know how to use certain functions on the calculator, so I'm gonna teach you. Right now, you need to get a calculator. It does not need to be a graphing calculator. I'm not a huge fan of graphing calculators during high school. In college, yes. In high school, no, we don't really need them. Just a nice smartphone will have a nice app on it. You want to have the kind where it's portrait mode, it's easy, but then you can turn it landscape and a bunch more buttons will pop up. That's what we're interested in. We specifically want to make sure you have these 3 buttons on your calculator. So if you don't have one handy, go run around right now and figure out where you're going to get one. Download an app to your phone if you don't have the kind that goes landscape style. Go steal one out of your older brother or sister's room. Just kidding, borrow, don't steal. But you know what I'm saying? Right now, go get one. Okay, come back when you're done. All right, these are the 3 buttons that you will see in a row, usually fairly close to the top of the calculator. This button is helpful anytime you want to square a number, and play with it right now. See what you can do. Enter 6 and then hit that button. You don't need an equal sign. It will give you the answer. Just play with it and see, oh, you just put in a number, hit that function key, and it will take the last number you entered and square it and show you what it is. Ditto for this one. If you want to cube a number, you enter the number, and then you hit this button and it will automatically cube it. No equal sign needed. This button is the one that you're gonna grow to love as I do. This allows you to customize what power you're raising it to. And this is how you do it. You enter the base number, which is equal to x. You don't have to say equal to x, but you just put in the base number, right? And we're gonna do it in just a minute. Then you tap this key, the XY key, then you enter the exponent you want. Obviously, if you want to raise it to the 2nd power or the 3rd power, you don't need to fuss with this key, but this allows you to customize your exponent and make it anything you want. And then, as I wrote here, you need to tap the equal sign to actually get your answer. All right? With the other ones, you don't have to tap the equal sign. With this one, you do. All right? So let's do the first problem, which is just this, just fooling around with this. We're going to evaluate this number using a calculator. 1.006 raised to the 8th power. All right? There is no 8th power button already set up, so we're going to have to use the custom one. So again, you're going to enter the base, which is 1.06. And then you're going to hit the XY key. And then you're going to enter the exponent, which is 8. And then you'll have to actually touch the equal sign. Okay, so these are the actual keys. This is my stylistic way of showing you individual keystrokes on your calculator. Right? I had to get creative there because those are all different. So you enter 1.06, then this, and that'll say, okay, take the last number and make that the X. Now take the next number and make that the Y. And then you have to signal to it, okay, I'm done now. And what you should get is a whole bunch of numbers. 1.59384875, depending on how many digits your calculator goes out. We want a lot. And an important part of using calculators is rounding, because they tend to give us more digits than we want. Here's my plea to you. Please, please, please do not truncate. Truncating is when we just chop off and say, okay, I'm rounding this to 3 digit, 1.593. No, that's not rounding. Rounding is when you remember the rule that you circle the digit you want to round, and then you look at the next one and you remember the rules of if it's between 0 to 4, you stay. And if it's from 5 to 9, you go up. That's rounding. Truncating is what students do when they start to feel a little bit lazy, and that's when you just chop off a number. You just artificially draw the line and say, okay. Obviously, it means it's kind of like always choosing to stay. But in this example, if I rounded this to 1.593, that would be wrong, because this tells me I should actually go up, doesn't it? So remember the rules for rounding whenever you use a calculator. Done preaching. Okay, now let's figure out what we're going to do with this calculation. I'm going to teach you the rest in context. All right. There are a lot of situations in life when things grow by exponential factors. COVID is such a perfect example of this. And in the future, COVID is going to be used as an example in math textbooks all over the world because it had such an interesting exponential growth pattern. But we're not going to talk about COVID. We're just going to talk about some other random, well, COVID's not a bacteria, but we're going to talk about bacteria growing in a petri dish. It triples every month. Oh, that tells us it's exponential growth. If there were 2,000, okay, so it triples every month. I'm going to jot some notes here. If there were 2,500 bacteria at first, heaven help the person who had to count them, how many in 10 months? How many bacteria were there in 10 months? What we need, my friends, is a formula. We need to plug this stuff in, don't we? And here is the formula that we need. The amount that we have at any certain time is equal to, and I'm going to write this all down, don't worry, the original amount, and Y is something we call a growth multiplier. I'll explain. And then T is the number of months. Okay, so let's write this down. A equals the amount. A with a little, you can see it as either a O or a 0, is the original amount. Some people remember this by going, oh, O stands for original amount, or some people see it as the amount when the time was equal to 0, and that's a 0. That makes a little more sense because AT equals the amount at time t, and t equals the time. Okay, well, I'll explain in a minute. It'll make more sense. Y is a special growth multiplier. In our example, we said it triples every month, so our growth multiplier is 3. All right, that you kind of have to feel your way into. So if we say that it triples every month, then that means that y equals 3, because 3 is the growth multiplier, and we see that ours is being tripled. So that's our growth multiplier. That's kind of confusing. I will grant you that. I'll give you a hint. Next year, we're going to change the way we're going to do similar problems, but we're going to change the way that growth multiplier thing is worded. John's simplifying it for you just a little bit. We'll go next year and it'll make more sense. Okay, so now we've got a formula and enough information to be dangerous. We're going to plug it in. We already said the fact that it triples every month. That's going to become our y. 2,500 at first. Oh, that's going to be our a to the 0, right? And then 10 months, that's going to be our t. Okay, so we're going to plug this in. We're going to say the amount at 10 months equals the original amount times y raised to the power of 10. Okay, so I'm going to take this. I'm going to write it down here first, and then I'll copy it to the other page. So the amount after 10 months is equal to the original amount, 2,500, times the multiplier, which we said is 3. So I'm going to put this in parentheses. Raised to the power of the time, t. See how I plug those in? Now I will copy to the next page. All right, now we're ready to grab our calculators and solve this. Like many calculator calculations, if we start at this end and work backwards, that actually is very helpful. So the first thing we're going to want to do is use this key that we just learned about to evaluate this. So we'll enter 3, and then we'll enter that key, and then we'll enter the 10. Then we'll hit the equal sign, and that will give us a value for this. Now, it's always tempting to stop and copy that down, but we don't have to do that. We go right on through, and we multiply it, and then this is following along. There's no break in the action. And then we're going to multiply it by 2,500. I'm not going to put those as individual keystrokes. All right, and then we might have to hit the equal sign again. All right, once we start a calculation in the calculator, we leave it there. We don't want to round things in the middle of the calculation or change our flow. We just keep going. So we're going to take 3, we're going to raise it to the 10th power using this key. We'll hit the equal sign, then we're going to multiply. I don't want you to get confused as to what that it might look like. It's the X key again, right? But this is just the basic multiply key, times 2,500 equals, and what we should get is that the amount we'll have after 10 months, it's a big, big number. Are you ready? It is 1.4762 times 10 to the 8th. That is how John's calculator shows the answer. Look and see what yours does. If you have any questions about how your calculator shows it, because calculators are different. So if you don't see this, reach out to me and say, what? And I'll help you. Okay, this is a great example of how exponential equations can help us in science problems. They can also help us in financial, in business questions, and with just a little bit of adjusting, we can use the same formula. Before it was this, right? This is the science. And we have all of these things defined on the other page, right? I told you all this, so I'm not going to write them all again. In business, we adjust this ever so slightly. This stays the same. This stays the same. But this is what changes. This is the finance. And you'll see that the only thing that's different is that what we called the multiplier, we're now writing in a completely different way. R equals the rate of interest. And I don't want to go too far down the financial rabbit hole, which I can do. I was an accounting major in college, and I worked in the business of public accounting for 6 years after that. So I love finance and accounting and business and numbers. That is a rabbit hole I can fall into. I don't want to do that. But 1 plus R tells you the amount of principal that you have plus the interest. So it's a way of saying, here's all the money you invested and here's the interest you earned on that. 1 plus R puts those two ideas together, all right? So what we're gonna do is another problem where we use this. The calculation will be exactly the same as the science-related one. It's just the way we write our multiplier is a little bit different. So here's the story. James deposited $500. Okay, that means the original amount of money was $500 at a rate of 7%, compounded annually. What does that mean? That seems scary and hard. That's just normal. Compounded annually means normal. Don't worry about it. How much money did he have after 14 years? So that's what, or a to the 14th is what we're trying to solve for. So let's write our equation. A to the 14th equals the original amount, $500, times 1 plus R. Now R is 7%, but we want to write that as a decimal. 1.07, right? Not 1.7, or I'm sorry, 0.7, no, 0.07, yes. 7% needs that 0 there. 1 plus that would be 1.07 raised to the 14th power. Lord have mercy. Thank goodness we have a calculator, right? Because who wants to do that? Okay, so this is what we want to solve. Sorry, it kind of got squished in with that. And again, we want to work backwards. So what we're going to do is we're going to enter 14. I won't show them individually. Then we're going to hit, oh, I'm sorry, my bad. We're going to start with 1.07. We start with the base. And that's helpful if you ever forget, because just look at the way the function key is written. It's x to the y. So you go alphabetically. The first number you enter, the calculator will put in the x place, and then the number that comes later is alphabetically later, so that becomes the y. 1.07 is the base, so we put that in first. Then we hit the function key. Then we hit the 14. Again, that would be multiple buttons, but I'm not going to show them all. You know how to enter 14. I don't have to show you that. Then we have to tap equals. It won't do it automatically. Okay. Then we have to multiply. So this button is the multiplication button. Again, just like I clarified that last time. Multiply. And then, whoop, we multiply by 500. Again, multiple keys, but you know how to do that. And what we'll get is that the amount that you have after 14 years is, and in finance, we always round to the nearest penny, right? The nearest cent. $1,289.27. We always put a dollar sign on business amounts. And that shows how much money he would have in the bank. How much money did he have after 14 years? There it is. Now, John asks us one more question. He says, how much interest did he earn? At first, that seems really confusing. But if you remember that this is how much he had after 14 years, and this is how much he put in the beginning, then the interest becomes really easy because it was 1289.27. That's the amount that he had after 14 years. And the amount that he had in the beginning was 500. He didn't put any more money in the bank, did he? He just let interest pile up on this. So that means he earned that much money is the interest that he earned. It's a lot of interest, isn't it? Which just goes to show that if you invest money at a young age, at even a decent interest rate, you will make bank. So save some money up and invest it. You won't be sorry. That's the answer to this question. All right, so there were two parts to the question. We had to answer them both. The last part of this lesson we are not going to do. The last part of this lesson involves using the graphing screen of a calculator to calculate an exponential equation. We're going to learn how to graph these later. I do not want to do it on the graphing calculator. I don't like students to use graphing calculators in high school. You'll get to them in college. Most entry-level college classes that I'm aware of those instructors do not expect you to know ahead of time how to use a graphing calculator. They will teach you. I prefer to stay focused on the numbers and not get distracted by pushing buttons and making pretty pictures. It's fun, it's easy, it's super easy. Don't be psyched out by it. I consider this a distraction. I want you to stay focused on the numbers. All right, so that is all we're gonna do. If there are any questions where John says use a graphing calculator to graph the functions, we're not gonna do that. We will graph them by hand later. So don't worry, you won't be missing out on that fun. We're just gonna do that. So no, I'm gonna use the exact words. Okay, so you don't need to use a graphing calculator to graph functions, and we're not sketching the functions yet either, because John hasn't really explained that very well. Next year we'll get into that. Okay? So I just want you to know these, be familiar with these problems just enough so that you don't do them. Use the graphing calculator to graph the function that is the, no, it would look the other way. And this is the kind of picture. No, we're not doing that. So skip. We are doing the calculations as we just did, and we're using a smart calculator or a smartphone to calculate the exponential values, but we're not using graphing calculators to make pictures. All right? The end. Goodbye.